Thank you very much. I'm honored to be here and sharing our journey with us. And when I say our journey, it's all of our journey. But I wanted to start by thanking some unsung heroes. We all do a lot of talks, and I think this is the most amazing audiovisual crew I've ever seen. So I want to start by giving them a big hand. So the journey here is, I want to talk about space. I'm Chief Technology and Innovation Officer at NASA's Jet Propulsion Laboratory, sometimes called Chief Toy Officer, and I wear that badge proudly. So I want to talk a little bit about that, and I want to take us on a journey, but the first thing that I want to talk about is, what do we do? Innovation comes in context of the organizations you work in. So let's see what JPL did and does.
The long-range purpose of unmanned exploration of the planets is the development of technology which will lead to eventual manned exploration. Scientifically, our objective is to assist in answering two basic questions. What, if any, life forms exist on the planets? And how has the solar system been formed?
I think one thing that must set apart JPL from other places is the willingness to take on challenges.
Reaching for something different, searching for answers. JPL has this tremendous tradition of being the first to do many things.
This legacy of firsts allows you to dream big, and you feel like you want to keep that track record going. You want to contribute to the next first.
Encouraging that spirit of innovation, JPL has been able to continue to dare mighty things.
I don't know what can be more exciting than that, when you're creating the science, creating the knowledge, creating the technologies.
The quest is the culmination of all these efforts we're doing.
It's bigger than any one of us. It's a quest for all of us.
So the fundamental questions have not changed, but we've had more questions now. And we use a lot of the tools that you use to address these questions. That's what I want to talk about today. Jim Whitehurst mentioned that this is the fourth industrial revolution. And it's any revolution, there's a lot of changes coming. So that's what we want to talk about. This is Jet Propulsion Laboratory. And if you were to come to visit, we don't have snow on the mountains. It's a little dry right now. But it looks very calm on the outside. Inside is a beehive of over 5,000 innovators that are curious, just asking questions, trying to figure things out. And the way we work is what's going to change, and you will all be part of that. I will go through that a little bit, but in essence, what do? We have cool spacecraft that send cool things down, and we try to do cool things with it. In essence, that's what we do. We have spacecraft in space, exploring what has never been explored before, and when you do that, some of the cool things happen. There are a lot of firsts that came out of JPL. There were a lot of, all of these things were big things. And sometimes a crisis is what you need to get to the next first. And I think the crisis now is the fourth industrial revolution, this power of participation, this open. So with all of those, a few of my favorites, since I'm talking, I can do that. The one on the left is Voyager, launched in 1977. It's 12 billion miles away, billion with a B. It's in interstellar space, truly interstellar space. It takes 18 hours for lights to reach us, and we can still communicate with it. The one on the other one, the rover, is one of the cars on Mars. And it has covered a human marathon already. And it's discovered things like Earth and Mars housed the conditions for life about the same time, about 4 billion years ago. And it's driving. It was supposed to last for 3 months. It's lasted 13 years. That's pretty good staying power. Now, contrary to popular belief, this is the first selfie on another planet. Was done way before Matt Damon did his video blog. So why did we do that? It took Curiosity, it took its giant robot arm, and it took a selfie so that we could make sure it's healthy. And it's also kind of a cool picture. So now you've seen Curiosity on Mars. That's what it actually looks like. So how do we, I'm in IT, how do we keep innovating in such a legacy of firsts? Well, we have to change how we work. So what we look at is what are the key disruptors that are facing us. Every 3 years, which we call an IT decade, we look at what's coming. And what's coming now is that in consumer space, lots of innovations is happening all the time. Your iPhones, your smartwatches, your Androids. And what we really want is we want to put them in an enterprise and use them. So I call myself the toy officer. Today's toy is tomorrow's tool, but we don't know which toy is tomorrow's tool. So we got to experiment. So what we do is we need a strategy for bringing those into the enterprise. So we came up with E4. And I'm sure you've all heard of that. Actually, you probably haven't because I made it up. E4 is just a strategy. It's a way of evaluating what's coming. It's engaging and enabling everyone and everything. You could call it the power of participation, both from people and things. So we're going to talk about Internet of Things. So if you look at this beautiful, you got to embrace them now, but if you look at this beautiful picture of a galaxy, can you spot the innovation? Can others create that innovation on our behalf? Will they care? So when we prototype and we try things, some of these will become stars that shines more brightly than others. And they're not necessarily created by us. So what's next on the innovation horizon? So let's take a journey here. Let's take a journey to the future. Let's take a galactic journey to other planets, but also a near-term journey about technologies, about what we prototype, and how we work. So if we look at how these toys evolve quickly, and we innovate very fast in the consumer space, in enterprise space, it's at glacial speed. It's very slow. So how do you tie it together? Well, what we found out is we look at the human behavior that affects IT, that affects human behavior. So if we can give the scientists and engineers that put rovers on Mars better tools quicker and see the disruptions coming, they will be even more productive, and it will help all of humanity. So that's the game. So if you look at these words, hopefully you see yourselves in there somewhere. If you don't, I really blew it. So I will talk about some of these as we go through it. I will focus a lot on IoT, Internet of Things. Absolutely. Is it a disruptor? Absolutely. Is it a toy? Yeah. Is it a security problem? Oh, yes. Is it useful? I really think it is. It's going to be extremely useful. But it's about prototyping. So here we go to the lighter side of space exploration. What do we do that one day will make it into space? So what we think, oh, by the way, when you looked at that, you looked at that eye chart with lots of things. I looked at the new technologies that have come up, the patents. It's slowing down from the 1700s to now. Are we living in a less innovative time? No. So what's happening is it's the combination of existing technologies that is creating these new opportunities. So what we need to do is to experiment with these things. And I'm going to talk a little bit about all of these, but I want to think about how we work. So how we work is open. So we're an enterprise, but we have some private things that are sensitive for various regulations. We live by the government regulations. But we can adopt the open development methodologies. So what you're seeing, each of these ticks, is how people collaborate in GitHub Enterprise, which we have inside. So we can now measure, we can look at it, we can see who's collaborating, and it has led to a tremendous decrease of organizational bureaucracy and a tremendous increase in code reuse. And this is one of the examples of that. So each of those ticks was a week. So what you're looking at here is analytics. Why do we care? Well, the Mars rovers that you just saw, they care about temperature. It can't be too cold or too hot for the instruments to work. They used to take a static screenshot and send it to each other and have an analyst look at the static screenshot. Now, by using cloud computing, we can copy all the data in by using open source. This happens to be Elk Stack. We can now look at all the data and have it at their fingertips, and they can interact with it. So they can see the highs and the lows of temperatures, and they can collaborate. Instead of sending a static screenshot, they send the state of analytics to somebody else. That somebody else may be on a beach, but we need the results right now. Very different way of working. And the other thing they can do, because they do that, when Curiosity landed on Mars almost 4 years ago, we put the pictures in the cloud, so you could see it right away. So now we could just click on one of those data points and bring up the pictures that Mars rover was taking at the time. Guess how long that took to implement that last piece? You know, usually we take a long time. This was done in 30 minutes. Because it was the combination of technologies. It was already there. That's really the key. So cloud computing was yesterday's toy. It was something 8 years ago when we started. What you did is you stored your music in the cloud. Now it's become today's tool. Those two spacecraft that you see here are SWAT and NISAR. They're radar instruments. They're going to circle Earth and looking for water to predict the floods and droughts and things like that. They are 80 times bigger than anything we've ever done before combined in terms of data. Will that fit in our data centers? We don't think so. So cloud computing is absolutely the innovators' tool, and it's going to be a tremendous thing. One day I knew that we would start in the cloud, and the one you see on your right there is kind of a cool mission. One day, we hope it won't happen, but an asteroid could get too close to Earth, and that would be a really bad day. So what can we do? We can go to an asteroid, capture it, or a boulder from it, drag it in orbit around the moon, and understand it, learn it, mine it, learn how to redirect it. That mission started in the cloud. So it became table stakes. So to engage and enable everyone and everything, what do we need to do? Simply act like a startup. JPL, as I mentioned, is this beehive of intrapreneurs. And they really are daring mighty things, just like startups do, doing something that has never been done before. So what we need to do is change from rules to principles, just like you already do. And to look at reducing overhead. Well, what is overhead? Overhead is when you're being prevented from doing something you know how to do because you have to wait for somebody. So it's a wait state. We can measure that. So that's changing how we work. Now, what else should we do? Use power of the crowd? Internet of Things. I want to take you to the lighter side of the world here. We want to be able to click it, combine it, look at it, blink it, all of these things that helps us how to interact with computing. And then we do something with it and we measure it. So I want to show you a few videos. Now, we don't have a marketing department. We're a bunch of geeks. We're scientists and engineers. So when you're seeing these small videos, it's somebody with an iPhone or Android videotaping somebody else who's doing something so we can talk about it. So let's take a look at this one. This is in our Innovation Experience Center. And if we can turn the volume up. Oops, here it comes.
Alexa, tell welcome to greet our guests.
Greetings. Welcome everyone. Here is where you can experience the future today. I am at your service.
Alexa, tell us about the IT guys.
Meet Phil. He can also build it. Mostly nocturnal. Allergic to Macs and JavaScript. Come to this guy with your architecture hopes and dreams.
So we can have
Alexa,
some fun.
Ask JPL what is an ORR.
It stands for Operational Readiness Review.
Alexa.
So it goes on, but the point is we're using consumer devices, and this time Amazon's Echo, to teach it to do JPL speak. We already have over 4,000 acronyms in there. You can just ask it. You can interact with displays and voice at the same time. So what can you do with that? And by being early adopters, and what we can do is we can influence the innovators in industry, you all, to build it in a way that we can use it. So we're doing that. So speaking to the room is very important because it's easy. So Innovation Experience Center is one place we play with that. Another thing we can do is we can gesture. So we can, instead of clicking, you can just use your arms like Microsoft Kinect started with. This happens to be Intel RealSense. And now we can move the solar system with our hands, or a model, the next model of a spacecraft. Very inexpensive consumer technology, and if people care when we show it, that's the whole point, then we keep doing it. If they don't, we drop it. And who are people? You are all part of this journey. So we want to figure out what matters. Now, we want to be able to use multiple senses, and afterwards I'll tell you if you want to hear how this came about. But it's analytics, multiple senses, and IoT. And cybersecurity is a problem. Well, let's see how we can deal with it. We built a device network where all our devices hook into that's not connected to the regular network. But let's listen to Mick as he explained it.
About how JPL uses Internet of Things and immersive analytics, this concept we've come up with, to enhance our cybersecurity awareness at JPL. For instance, we have data coming in off of our firewall in real time about where the attacks are coming from, where the traffic is coming from, and using analytics we can decide what's normal, what's abnormal. For instance, we can assign a note on the piano keyboard to each country that traffic is coming in from with representative data, and actually listen to your firewall. You can hear when it speeds up, you can hear when it slows down, you can be navigating away at other pages and still get beginning insights in real time as to the state of your firewall. Another thing that we can do is use consumer devices, smart light bulbs that change colors programmatically or with your phone, so that we can actually look at, for instance, how much traffic is being blocked or let in, and we can actually update the colors of the lights in the room in real time based on our firewall. If I make it some representative random data, you can see, of course, watching the colors of the room change in real time. This is also very powerful because if I'm doing normal work or something else and the colors of the lights in the room change, this is a very obvious indicator that something has occurred if I need to take action.
So lights are all over JPL, so it's situation awareness. All of a sudden you're aware that something is going on, just using consumer technology in new ways. We were giving a demo to Danny Mac, for you Red Hatters, you probably know him, and Mick was working on a Twitter demo, and all of a sudden Mick goes, he said the S word, and then he said, "Can't you hear it?" And we go, "No." "Well, that's the point. It stopped playing." So he switched over to that the dashboard and saw we had a denial of service attack that just started. One of the countries was pegged red. Called the cybersecurity office, and they said, "Okay, we saw it, we're on it." In seconds, by working on something else. So now we apply machine learning and things like that. It mattered. It was important. 3D printing is a huge opportunity. So we've explored 3D printed. We bought it and gave it to people who might do something interesting with it. This is something interesting. So we made 3D printers, robots that climb, that swim, and it's fun, but you can iterate so much faster. So today's toy becomes tomorrow's tool. So here it is again, just like a gecko would climb, they're microscopic fibers. We played with it in our lab and said one day maybe it could clean the solar panels on the space station. And here it is in the Vomit Comet, simulating zero gravity, and in fact it works. So that is going to go on the space station, but it's this rapid experimentation that creates things faster and much lighter weight than we ever thought possible. Interplanetary collaboration is a big deal. We can explore it with augmented reality. We started with Google Glass, now we're using Microsoft HoloLens, we'll use the next one. People are going to sit at JPL and explore Mars virtually. We are now exploring building spacecraft where you can walk inside the model and move the cables around, see if your hands will fit. Things like that, and we're just scratching the surface. So what are some of the key questions that you will all help us with answer? Where could we find life? Imagine that you had a big ice ball and with rocks inside, and you toss it in orbit around Jupiter. That's what Europa looks like. It is orbiting Jupiter, and it has a very smooth surface, so the ice is shifting. One day, we may have this travel poster where you can go to Europa. We're sending a spacecraft to orbit. It's going to land, one day melt itself through the ice, become a submarine, and see if there are aliens there. Because there are 2 times the amount of water on Europa than there are on Earth. And water is the secret to life, we believe. Another one is, did Mars ever house life? This could be Death Valley, if you've ever seen it. And there was running water, so what happened? There was oxygen, so what happened? And what we might find out is we send a 3D printer up to build bricks, take the soil, build bricks, make houses so the radiation won't kill people, and then send a helicopter. Mars helicopter, it's 1% of our atmosphere, so that's like flying a helicopter at 100,000 feet, and we've demonstrated we can do it. So it's that collaboration, it's that innovation we're looking for. If one day we needed to export humanity, would we have a place to go? Earth 2.0 was found by Kepler. This is in the habitable zone, so it's where people could potentially live. It's pretty far away, but we found 1,000 of them so far. This was the NASA Space App Challenge a month ago, where we had 15,000 people at the same time collaborating, and hopefully some of you were part of it. It was in Pasadena, and you can see that was one of the locations where I was at. You can see them work. We judged it, and now you had a winner who ended up being the whole winner of all the global for data with a 30-second video. So it's how you get your message out. And they actually built a device that measured the air. We need to engage our stakeholders. So JPL's open house was held a few weeks ago. That's our future explorers. They're all Martian roadkills, and they love it. Now here is today's toy. It's a 360 video taken by a small device that just sits on the Mars rover. So I wanted to show you JPL's open house from the Mars rover's point of view. Very inexpensive. If I had my 3D glasses, it would look much nicer. But the idea is you can now visit places in person that you could not otherwise visit, or visit it virtually. Finally, how do we understand our solar system? Power of participation. You can all participate. On July 4th, it's amazing how many things happen on July 4th. Juno is going to go into orbit around Jupiter. It'll slow itself down by 12,000 miles per hour in 35 minutes, be captured by the gravity of Jupiter, and spend 20 months looking to understand this gas giant. And we want you to participate. The citizens will pick what pictures are going to be taken, how they will be processed, and so really, please help us. Be a citizen scientist. We have to evolve how we work, and that's really the big journey now, and that's the journey we all want you to participate on. It's all about collective crowdsourcing. It's all about open source, doing something that we can continue with, and we want to engage and enable all of us with everything. And we need to learn from others. So these are some of books that are talking about how we innovate the organization and where we go, and I think that's really key. So how do we go about this? First of all, I want to see if there's anybody from NASA or JPL in the audience. Would you stand up, please? Don't be shy. It's to be recognized. If there's anybody standing up, everybody else see who it is so that we can collaborate and talk afterwards. Certainly can't talk to me, but to all of them. And to embark together on this journey to, not for us necessarily, but for our children and our grandchildren, to save and protect Mother Earth, find life out there, find Earth 2.0, redirect an asteroid, and we're going to do all that just the way when the orchestra was in here. They played music. The future is, imagine an orchestra. We just know that we want to hear beautiful music. We don't know what instruments are there. We don't know how they will play, but we know we'll get there together. And that's the power of participation, and I thank you very much for your attention.